Have you ever wondered how scientists determine the concentration of an unknown solution? It's a fascinating process known as titration, which is a common laboratory technique used to figure out the exact amount of a substance in a solution. Today we'll take a journey through a titration experiment using sodium hydroxide and hydrochloric acid, with a phenolphthalein indicator as our guide. Imagine a laboratory where you'll find materials such as a sodium hydroxide solution of known concentration, hydrochloric acid solution of unknown concentration, distilled water, phenolphthalein indicator, a burette, pipette, Erlenmeyer flask, and a stirring rod. The first step involves rinsing the burette with distilled water, followed by the sodium hydroxide solution. Then a fixed volume of the hydrochloric acid solution is measured using a pipette and transferred to an Erlenmeyer flask. In this vessel known as a flask, we carefully introduce a modest quantity of phenolphthalein indicator. The purpose of this chemical is to serve as an indicator, highlighting the changes in acidity levels of the solution. Upon the addition of phenolphthalein, the solution notably takes on a colorless appearance. This transformation occurs because in a neutral or acidic state, is colorless. The thrill heightens as we approach the critical juncture. The controlled addition of the sodium hydroxide solution from a calibrated glass tube called the burette into the Erlenmeyer flask, which already houses the hydrochloric acid solution. This stage is where the real magic happens. An important part of this procedure is the constant stirring with a stirring rod. This isn't done at random, but serves a significant purpose. Continuous stirring ensures that the sodium hydroxide being added from the burette and the acid in the flask mix thoroughly and react completely. It is vital to the accuracy of the titration process as it ensures equal distribution of the reactants, resulting in a precise endpoint of the reaction. The sodium hydroxide solution is added slowly, drop by drop, until the endpoint is reached. This endpoint is signified by a change in color from colorless to pink, indicating that all the hydrochloric acid has reacted with the sodium hydroxide and the solution is now neutral. The volume of sodium hydroxide solution used to reach the endpoint is recorded. This process is repeated 2 more times to ensure consistent results. After calculating the average volume of sodium hydroxide solution used to reach the endpoint, it's possible to calculate the concentration of the hydrochloric acid solution. To wrap it up, the balanced chemical equation for the reaction between sodium hydroxide and hydrochloric acid is NaOH plus HCl, NaCl plus H2O, and the mole ratio of sodium hydroxide to hydrochloric acid is 1:1. Therefore, the number of moles of sodium hydroxide used is equal to the number of moles of hydrochloric acid in the reaction. Following the formula for calculating the number of moles, the concentration of hydrochloric acid can be calculated by repeating the titration 2 more times and taking the average volume of sodium hydroxide solution used. A more accurate result for the concentration of hydrochloric acid can be obtained. This, my friends, is the magic of titration. It's a precise and efficient way of determining the concentration of an unknown solution, and it's a testament to the power and precision of science. So the next time someone asks you about titration, you'll know exactly what to say. This video has been a product of Open Learn Academy Kenya. For more enlightening and engaging content, do follow and subscribe to their channel. And remember, always clean all equipment thoroughly after use to prevent contamination of subsequent experiments. Until next time, keep exploring the wonders of science.